Good evening, everyone. Welcome to our first historic presentation night of the year. Thank you all for taking the time out of your day to be here. Tonight's presentation takes us inside the Michigan Storm Chasers. They're an independent organization dedicated to delivering life-saving weather information across the state. We'll explore the group's history, what a typical chase day looks like, and how they approach severe weather forecasting. Our speaker this evening is Joel Fritzma. He is the chief meteorologist of the Michigan Storm Chasers. Joel has been chasing storms since he first received his license in 2015. Along with other weather enthusiasts, he helped found the Michigan Storm Chasers in 2022, and since graduating with degrees in meteorology and geographic information systems, he has been able to turn his passion into a full-time career. Everybody now, if you could silence or turn off your phones. If you need to leave at any point during this, do that through the door behind you. And then if you have any questions, save them for the end and he will have time to answer those for you. But everybody please welcome Joel Fritzma.
Thank you, everybody. Well, good evening. I am Joel Fritzma. I am the chief meteorologist of Michigan Storm Chasers, and this presentation tonight will kind of deep dive into a lot of different things that go with the field of meteorology, including what we do at Michigan Storm Chasers, which is the field of digital meteorology, which is relatively new. The whole rundown looks like this. So you get to learn about me to start, and we'll talk about some meteorology careers besides digital meteorology, broadcast meteorology. Talk about our storyline at Michigan Storm Chasers. We'll include aviation into meteorology in the middle portion of the presentation. Then we'll dive into severe weather forecasting, lake effect snow, how to read radar and even detect tornadoes on radar yourself. And then we'll talk about the day in the life of a storm chaser at the end, and of course, how to be prepared for severe weather. Any questions can be held towards the end.
Yay.
Yeah. There we go. Oh, we went twice. There we go. So a little bit about me. I was born and raised in Lowell, about 2 hours from here, 20 minutes east of Grand Rapids. My hobbies growing up and still are playing and watching sports. Go Lions, go all Detroit sports teams, of course. Fun fact, I do a lot of line dancing over on the west side of the state in my free time. And when I do have free time, which isn't a whole lot, but I do play just games, you name it, board games, video games. Played a lot of golf and tennis in high school. Some people call them the boring sports, but they're awesome. I don't know why people dog on them. They're really fun. So, a unique fact about me, though, I've been to 48 states, not just in a certain time, but before the age of 21. I got to see a lot of different weather phenomena during that time. I give a lot of credit to my family. We did a family vacation every summer. We would pick a different region of the nation to go to every single summer. So I got to see everything, and for those who are wondering, the 2 states I haven't been to yet, of course, Alaska and Hawaii, a little harder to get to, of course. As mentioned, I do have 2 degrees, meteorology and GIS. For those who don't know what GIS entails, that is for digital mapping, so cartography. A lot of different companies need that, and with mapping and with meteorology, there's a lot of similarities in combining things, and so the tools I use in GIS go right into meteorology, so it's pretty cool to use what I used in both degrees. On top of that, you'll learn here in just a second, meteorology has a lot of mathematics. So in the process of getting my meteorology degree, I picked up a mathematics minor. I was a storm chaser since I got my driver's license, so tornadoes are indeed my favorite weather phenomenon. And my first ever job was actually as a scorekeeper at an ice arena over in Grand Rapids. I also worked at a golf course, and I kid you not, for 2 summers I had an internship putting cameras down in sewers. So, it was very fun. I didn't get too dirty. I didn't actually go down there myself, but cleaning off the camera was a mess. And so, my advice, of course, is this job you first start at won't be the one that you typically end up at. So, that's a little bit about me. My whole path actually started in first grade. So, a lot of people don't have a childhood dream that comes true. And for me, my childhood dream did start in first grade. I kid you not, I was not paying attention in class. I was looking outside, out the window, at the clouds, and my first grade teacher, Mrs. Hughes, noticed that. And she was like, we have this thing called the weather person of the day. How would you like to try it out for a week at a time? Then we'll let the rest of your classmates do it. It's like, you know what, let's do it. I fell in love with it right then and there, and on top of that, I went home and watched the Weather Channel basically all the time. Some of you guys who might be familiar with severe weather, there was a severe weather outbreak in the southeast states in 2011, April 2011. And that was on the Weather Channel. There was like 9 hours straight of severe weather coverage that day. And that kind of got me more interested. Some of you guys may also be familiar with a famous storm chaser by the name of Reed Timmer. He drives a armored vehicle into tornadoes, I kid you not. And I actually got to see it at the National Weather Service in, I think it was 2008 up in Grand Rapids. That's me, next to Reed Timmer back then. I somehow found the picture. And yeah, he looks a lot younger. I look a lot younger back then. But it's pretty cool to see the storm chasing side of things and learn about that and how you can actually make a career actually out of storm chasing as well. Down in this photo right here, that's me in high school, about 7 short years ago now. I took a video broadcasting class, and what that entailed is it's the daily announcements. It was all that stuff. I was the executive director my senior year, so I got to basically do whatever I want, and the only thing I did, of course, was the weather. So every Monday, I would stand up in front of the entire school and just give a national weather report, regional, and on the days that wasn't Monday, I would just do tiny little segments to kind of fill the gaps. And then for college, I actually started at Grand Rapids Community College, got some core classes out of the way, which was pretty smart. Transferred to CMU and ended up graduating. It wasn't the typical 4 years, it was a tough degree. It ended up being 6.5, and because of multiple things here. Number one, it was multiple degrees. Number two, as I mentioned, there is a lot of math. You can see the entire list. This is the entire meteorological curriculum here at CMU. CMU is the only university in the state of Michigan that does have a meteorology program. University of Michigan does have classes. They don't have a full program, so it's lumped in with their geography department, just a disclaimer there. But the classes there in orange specifically, those are the ones I will admit I had to retake because they were difficult. Calculus 1, Calculus 2, Calculus 3. I have very bad memories of those. But this one right here, this is what we call the make or break class in meteorology, atmospheric thermodynamics. All those classes basically above atmospheric thermodynamics are tossed into one class right there, which is atmospheric thermodynamics. And so, didn't make it through the first time, put my head down, got to it, and got through it the second time. So, the fun classes are in green, of course. Real quick fact about this one down here, mesoskill meteorology, that's a class dedicated to just learning about thunderstorms. So, you know, they save the best for last, of course, and so I had to wait until my senior year to take that class. Now, as you guys have been reading some of the bullet points up here on the screen, it was 71 of my 124 credits I did have to take. I started with 35 in my meteorology program. I graduated with 9, so it was a very tough program. I lost a lot of people along the way, but again, it is a tough degree. And for anyone in here that may be going to college, of course, it goes for any program. Tutoring, found that out the hard way right off the bat when I went right to college at the ripe old age of 18, that you need to tutor, you need to get tutoring lessons because you will not make it in a program this difficult. So I tried the first semester without it, bad idea, and make friends in your program because, again, you guys are going to be taking the exact same classes, and ultimately when you guys are helping each other out prior to exams, it's going to make so much more sense than just to do it on your own. So here are some of the careers in meteorology. Obviously, digital meteorology is brand new. It's kind of, with the advancement of social media, kind of up and coming. But up here, academia, I was in college for too long, I didn't want to go back. But for those who do, master's program, research, PhD if you wanted to teach, that's an option. Forensics is very niche. So that would be the court system, for example. If you had someone come up to you and say, hey, my house got hit by a hailstorm, but my insurance company's not paying out. Can you prove to me that this hail actually happened? And I would just go ahead and say, yeah, I'll go dive into it, get all the details, and send them your way. So that's forensics. I took a look at that for a little bit, and again, there's not too many forensic meteorologists out there, but it is a field. Transportation, a lot of railroads, a lot of airports. Every airport has a meteorologist on staff. You think of BNSF, Union Pacific, CSX, all those different railroads do have meteorologists on staff. Public Works, DTE, Consumers Energy, all the electrical companies usually have meteorologists on staff. I've met a couple of them before. And over there to round out the first row, radar technician. So the golf balls in the sky that you see at some of the airports, those are the weather radars, and people need to repair them, otherwise we can't see the rain that's incoming. So with a meteorology degree and some background training, you can become a radar technician. So again, digital meteorology is up and coming. It's all social media based. It's basically broadcast meteorology, but not on TV, and so that's kind of where the difference is here. Obviously, you can work at the National Weather Service. We have 4 in the state of Michigan. And if none of these options work, you can go into the military. So a little bit about us to start. I'm right there in the middle, of course, Chief Meteorologist for Michigan Storm Chasers. Ryan and Chandler are kind of our head honchos, our president and vice president. They got all the stuff going on behind the scenes, the stuff that you don't usually see that is on our Facebook page. Alex also went to CMU for a little bit for a meteorology degree. And so we actually hired him on full-time this year. Some of you guys who do follow our page got the news on that. Caleb also is full-time staff, but he runs our Indiana operations. For those who don't know, we do have Indiana pages that we run, but he lives in Indiana, and so he runs those pages kind of on his own. And then down here at the bottom, we do have Lydia and Matthew. They are office manager and lead videographer. Again, there's a lot of organization that everyone has a part in doing here at Michigan Storm Chasers. So 7 primary staff. And with all of our storm chasers, they're not listed up here, but we have about 20 of us total. And again, we shout out our storm chasers because those are the ones getting you guys the view in the field. So here's the timeline. I won't read through it all. You guys can kind of look through it for yourselves here. But the first and foremost thing here is in 2022, we weren't really recognized at all. We were putting in a lot of time, money, effort into just getting noticed on the algorithms on these social media pages. But in 2023, we really started to kind of ramp up our live stream coverage. We started off with the goal of getting your guys' public severe weather reports into the National Weather Service, kind of a branch in communication. We didn't realize the untapped potential in live stream coverage. So we tried it in April. Then it really started to take off in August of 2023. Some of you guys may remember the Weberville tornado right up the road. That was one of our biggest streams that we had up until that point, and we had a lot of positive feedback, and we realized that there is a huge calling for this type of on your phone live stream coverage if you guys especially don't have TV. Once we get to 2024, we started to branch into Aurora, and then of course part-time staff we were able to hire. And then as we got into 2025, right when I graduated out of CMU, I was able to be hired on full-time, and a couple of our other employees as well. And then in 2026, we are now diving into weather monitoring. So if you're going to an amphitheater or a casino, there's some of these companies that are reaching out to us to get them personalized forecasts for their events. So that's something we're trying out. Nothing's changing operationally for our social media pages, but behind the scenes, just know that we are also privately forecasting for a couple companies around the state. There we go. So this is part 1 of the office. This is actually my room. So I'm the only one actually that isn't in our office. I'm the one that works remote from home. So as you can see right here, this laptop is what ran Michigan Storm Chasers for the first 3 years. As we continued to grow, realized that laptop's not going to make it too much longer, so we had to build a completely new setup. And this goes for not just myself, but Ryan and Alex and Chandler as well, because again, we have so many followers now, and there's such a high demand for live stream coverage, and this laptop can't really handle that. Additionally, for those who are interested in ArcGIS or know what ArcGIS is, that program cannot be run on this computer, and so we needed to upgrade quickly. And so this is my current setup. A lot of different stuff here. I had to custom build that PC, and for when we're live, obviously a green screen and a TV over to the side so I can actually point and see to what I'm looking at. But this is our office. We just moved in. It's down in Constantine, so down by the Indiana-Michigan state line. That's where a lot of our staff are located. So me being up in Lowell, I can't really make it there in a reasonable time. So I'm still working from home, but this is where our office is. And again, it's really small, but it gets the job done, and a lot of our operations will be held here going forward in 2026. Some of our connections, obviously first and foremost, with our goal in mind to get the information from you guys to the National Weather Service. National Weather Service damage relay is important, and it will aid ultimately in faster warning time for you guys. We do communicate with the news stations as well. We make sure that we're kind of on the same page when it comes to critical information. Storm spotters, we do rely on storm spotters both in our program and outside. So some of you guys in here might be part of the Skywarn program that the National Weather Service runs. We do reach out to you guys as well. emergency management and sponsors, that goes back to weather monitoring. If they have an event that's going on, we will reach out to them and tell them, hey, you might need to suspend operations because there's severe weather heading your way. And lastly, you guys are a huge asset for Michigan Storm Chasers. Ultimately, you guys are helping the page with your comments, direct messages, and just putting your damage reports in the chat, no matter what platform that you follow us on. So, some tips of being successful here at Michigan Storm Chasers. We do have just this commitment to Michigan without restrictions. The main reason why I mentioned that is we can go live really at any time. The news stations do a really good job of going live when they can, but we can just tune in at 1:30 in the morning, 1:30 in the afternoon, you name it, and we can stay live for 24 hours. A lot of news stations, they can, or they may not be able to. They have to translate over to social media instead. And so that's kind of where our continued commitment jumps in. Accuracy and forecasting, this comes in for winter weather coverage this year. We strive for 80% or better. If we were 100%, we wouldn't be human, so that's why we aim for 80% there. And again, we do have meteorologists on staff. Extensive radar knowledge, calling tornadoes ahead of time. We've done this twice. Number one was the Grand Blanc tornado. Number two, there was a tornado on the same day as Weberville over in Comstock Park, Michigan, north of Grand Rapids. We called both of those tornadoes between 10 to 20 minutes in advance of them even touching down. And so that's where that extensive radar knowledge comes in, and that kind of comes with the territory of being a meteorologist. Again, we just have a general passion to keep people safe. Again, I have a huge love for the science. That's something I knew I wanted to do since first grade. And so making sure people are safe and also educating along the way is ultimately really fun. And I want to make sure that you guys can also learn if you really want to, or at the very least, stay safe. Trustworthy, communicate well, and throughout the event. Again, our policy, as you'll hear here in just a second, is from beginning to end, and that will never change. So this is what it looks like. Some pretty pictures here. The whole rundown, mostly for severe weather coverage, sometimes for winter weather, but this is primarily for severe weather coverage during the spring, the summer, and the fall. About 3 days out, we start making these in-house forecasts that you can see down here at the bottom left side of the screen. These in-house forecasts, we try not to do higher than 3 days out, because at that point you start to get confusion with the general public, and we want to make sure that if there's overlapping days, if there's 2 days in the same week that are going to be severe, we want to make sure that we're not jumping ahead. So we'll usually wait until about 1 to 3 days prior, and then we'll start rolling out these forecasts, which, as you can see there, 45 minutes each, and that includes the write-up that goes with this. And I used to have an old slide that said about 45 to 90 minutes. That is still true. It does take a while to make these forecasts. Now, about 12 to 48 hours out, we start hosting live streams for you guys to tune in. So these briefings entail where the strongest storms are going to be, timing, ingredients that are available for storms to develop, and then ultimately, if we didn't cover anything, we will take your questions in chat and then try and answer as many as possible. Now understand, if you guys do follow us and tune into our live streams, sometimes there's going to be a lot of people watching. And ultimately, we can't get to every question in a reasonable amount of time, so we'll always try and pick and choose the questions that will answer for the most people. So just know that as a disclaimer right now. Again, we do have a lot of people that tune into these briefings, and sometimes it is a little overwhelming in chat to read through them all. Less than 24 hours out, we got to figure out where everyone's going to be. Myself, I'll probably be hosting the live streams as usual, and then we'll have our storm chasers out there in the field, and we got to figure out where they're going to be throughout the state so we can maximize the most views for you guys, so you can turn your inactive mindset into a reactive mindset. Because again, in the day and age of technology, everyone's already got their heads kind of buried in their phones, and so we want to make sure that the image is there, so when you see it, you can make that decision to go and take shelter. 1 to 5 hours out, this doesn't happen for every event, but for some of the strongest events, we do internal discussions. These are what we call mini impact forecasts. So it's just, if we circle an area of the state saying, hey, this is where tornadoes are going to happen in the next couple hours, it's just basically what that entails. And then again, as that first warning happens, we are dropping everything and we are going live, BTE, beginning to end. And as an example of that, last summer, we went live up for storms in the UP at 1 in the morning. Take a guess what time we stopped that stream. Someone can just shout it out. In the afternoon. You were close. Yeah. We stopped our live stream at noon the following day. So it was an 11-hour stream. And just to give you guys an idea of that BT policy as well, we haven't missed covering a single severe thunderstorm warning. These are the 2 warnings we go live for, by the way, tornado and severe. We haven't missed a single warning anywhere in the state of Michigan since the end of 2023. So for the last over 2 years, we've been live for every single warning around the state of Michigan. In total, that was about 200. So we've been live quite a few times throughout the last 2 years. So these are just some examples of our live coverage, and you'll get to see a video here in the next slide of this stream in particular. This was May 15th. This was our most watched live stream of all time. This was last year. Some of you guys may remember this. We had, I believe, 2 tornadoes over here on this side of the state. Most of them happened over on the west side of the state in the Grand Rapids area, but we did, I think, have one down in Milan, and there was one up north of Flint as well. But again, that was our most watched stream, and again, these are where we kind of lock in, and it's all serious, and we want to make sure that we're covering every single warning up and down the line to the best of our abilities, because in this event, on this day, there was 20 warnings going on, and so we had to go boom, 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 right back to the top again, boom, 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 and just make sure we keep repeating all the information up and down the line. Compare that to our winter weather stream. More laid back, we're just driving around, checking out where the heaviest snow has fallen, maybe some road conditions, and we do have a lot of free time. So much so that if you look here closely, if you look at the side of the screen over there, our chaser Tyler is making a snow angel on our live stream. So again, it's more laid back, and these winter weather live streams are less attended, and so we get to hang out with you guys as well and chat. And so usually during those live streams, when you have a question, we can easily answer it. Down there, you guys, for those who do follow us already, have been aware of our disaster relief, particularly with the latest ice storm that happened down in Mississippi, but last year. We also did it for the first time up in northern Michigan because it was a huge event that unfortunately wasn't covered well, and so we wanted to make sure that the resources were getting up there. We reached out to everyone across the state, and we all came together to donate over $100,000 worth of supplies. Also shout out to Sam's Club in Traverse City. They were also able to supply us with supplies on them. And we went to about 15 or 20 different cities around northern Michigan to hand those out on 2 separate weekends. And all of the supplies, all 100% of it, all ran out. We completely ran out of stuff. Everyone desperately needed that. And for those who don't realize how grave it was last year, for some locations, the power grid had to be 95% rebuilt. And in some cases, that meant some people's power was out for 8 weeks. And so we had stories of people coming up to us, driving with their neighbors because ultimately they can't get out of their driveway because I had 30 trees down and it just took forever to clear. So there's just some stories that we remember from this event that we'll always take to heart. And anytime severe weather happens again or a natural disaster happens in Michigan again, we'll be ready to mobilize and make sure to reach out to you guys that really need it. So this will be the video of our live severe weather coverage. It should have sound, but
you're not in it yet.
Okay, it does.
But you can see what's heading your way. A line of destructive winds, previously destructive winds, now kind of downgrading to about 60 to 70, but still a threat for.
this is May 15th.
A couple of emitted tornadoes heading your way. So again, if you're in Lansing area, be on alert soon. County and a half away now.
I have a new scanner on the CC that is on the ground again, just to the west and south of Hastings. Very clear-cut debris ball there, back on the ground. Maybe a new scan here, hopefully.
Yep.
Call some road names out there. Let's do have it there. I don't have any roads.
Yep, I got it. So it's going to be over Havens Road at the intersection of Havens and an unnamed drive. So it's Havens there. I believe there's probably some lakes in the area. Goodwill Road at Haven as well, and Goodwill at Airway. So
It's the wildlife.
Goodwill, and Ross Road south of Goodwill, and Hubble Road north of Goodwill. Again, this is heading kind of off to the northeast. This would be heading towards downtown Hastings. That is a very populated area. Please be taking shelter if you are in Hastings. This is still an observed tornado warning for a tornado on the ground. It looks like it's picking up for a brief moment. It is now back on the ground again.
So again, that's just a 1-minute clip of our severe weather coverage that night. We were live for about 7 or 8 hours that night, if I recall correctly. Again, there was 12 tornadoes that night, and just to give you guys an idea of our live streams, again, we're always going to have a face to a name so you can always see who's on during the live stream. We'll often have our cameras up here as well in the corner, and then down here, similar to what the news has with their, their school closings, we have instead of school closings, we have active alerts. So highest active alert will always be displayed on the top of the screen, and then we'll have our scroller. You can't really see it because the bottom bars are in the way, but all active alerts are going to be scrolling at the bottom of the screen throughout the stream. So if we're not covering your storm at that point, you can see if your county is in a severe warning during the event. So that is an example of our severe weather coverage. Now, the day in the life of Michigan storm chasers here, obviously we don't get severe weather 365 days a year, so we have to fill some of the gaps. Now, when we do have severe weather, active live stream operations is what takes primary focus. But up at the top of the screen, we release forecasts 365 days a year, no matter the day, holidays, weekends. I worked probably 320 days this past year, something like that. It was crazy. But again, we're dedicated to making sure all this information is getting out to you guys. Secondly, I'm here in person with you guys tonight, and so we do educational presentations, and so sometimes we go here, schools, colleges, and even libraries as a presenter, and in some cases I've gone to firehouses and police stations to do kind of like a storm chasing kind of advice, how to spot the clouds and whatnot, so a bunch of different opportunities there. Fill the gaps with fun or educational posts, we'll see this in just a second. We do like to make it lighthearted on days where there's nothing going on, so you'll see memes, weather educational posts, and the likes. So, coordinate and take part in disaster relief, already explained that there. And again, weather monitoring is the next one. How many of you guys have seen the Northern Lights? Sweet, about half of you guys in here. We do post about the Northern Lights as well. They are very cool to see. And right now, in Michigan, we are in what's called solar maximum. And so, 2024, 2025, we're kind of dipping off now here in 2026. There's the maximum amount of sunspots on the sun. And so this happens every 11 years. So once we get to 2030, 2031, it'll be at minimum again. But as it stands right now, we have a lot of northern lights going on, so we're able to kind of cover that for you guys. And that goes with our weather cameras down there, which is what we do in our free time as well. And make sure they're staying maintained. Now, here's some of our fun graphics that you can see. The one on the left is our funniest one that everyone gets a kick out of. It's called the trash can window meter. And what this is entailing is winds equal to what your trash can will do. So level 1, your lid flips open. That's about 15, 20 mile per hour winds if you have a light trash can. You get to 20 to 30, that's when your can gets knocked over. And then our favorite category that everyone gets a kick out of is neighbor's yard. The name of the neighbor always changes. So in this example, it's Kelly. It could be Steve. It could be Joel. It changes every single event. And so that is, every time there's 30 to 40 mile per hour winds in the state of Michigan, we're always looking to see if we can issue a level 3 there for the trash can window meter. But if we get above that, obviously you have your trash can getting knocked 3 blocks over. And level 5, which is very rare, 50 mile per hour winds plus, that would be blown to Canada. Here's some of our educational graphics that we made. This one's about the wind chill. This one's about the recent frost quakes that we had. There wasn't too many, but there was a risk of that. This is what our daily conditions look like. So this was 2 days ago. If you guys remember the day we had freezing drizzle, that was what our forecast looked like for the day. You could see down at the bottom of the screen, freezing drizzle possible, but it's an entire picture of the state with temperatures and weather conditions, and not shown, but on our Facebook page, all our social media pages, you can see a write-up that goes with the graphic. Also, for certain winter weather events, especially winter storms, we do verifications. This is where we talk about our 80% accuracy rating. We run it through a computer algorithm to make sure that it is to the nearest percentage. And this was our best one of the winter, 89%. We did have one day that you guys probably remember where every single meteorologist in the state got it wrong. When we had trace to 1, and then the models also said trace to 1, every single one said trace to 1. And then about 1 hour before the snow starts, oh, there's 6 inches of snow that's gonna fall. Well, that's a little too late for us to get a forecast out, and so everyone failed on that day, but again, usually we're about 80%, besides that one that happened there. So we wanna make sure that transparency is also key, and when we're right, we wanna make sure that it's out for you guys, and when we're wrong, we wanna make sure that it's out for you guys as well. So those are some of our graphics that you'll see on our social media pages. This is our weather camera network. This is what everyone loves to watch sometimes in the free time. Now these weather cameras are important because they capture severe weather in your neighborhood. Also, fun things like this, such as meteorites, and of course, the northern lights. So this is a meteorite that fell back in November of 2025. It's the same one in 4 different locations of the state. A little bit about our weather camera network is we started this about 10 or 11 months ago. And to this day, we just installed one today over in Grand Rapids. We've reached 96 cameras installed across the state of Michigan in 10 months. So it's been a long process, but we're continuing to get cameras going. And the way this all works is the business pays for the camera, and in return, we give them exposure-based advertising, as huge in the day and age of social media, because again, last year in 2025, for those who don't remember, I think we posted about it on our Facebook page, we had 1 billion views on our Facebook page in 2025 alone. So exposure-based advertising is huge for some of these businesses, and the camera install only costs them like $2,000. So if they can get a camera and a bunch of exposure-based advertising out of it, then it's a huge win-win for everybody involved. Here's some of the northern lights. Very, very cool, very, very vibrant. This right here is the northern shores of Lake Michigan in Nobbinway, and over here is the Lower Peninsula. So this is Bayport, up in the thumb, and Ludington, Michigan, over there northwest lower. So these cameras do good in both daytime and nighttime environments. As you can see here, the night sky is showing up rather nicely. Now we get to move into meteorology and aviation. I have a little segment about this. It's not completely in deep dive, but this is some of the stuff that we use for aviation and meteorology cross together. Now, for those in here, all pilots are usually trained in reading weather reports, specifically METARs down here at the bottom of the screen, which is our third bullet point there. These METARs are what we are trained on. I will sidetrack here for a second, I actually took a drone class at CMU, and we got to learn about METAR stations. I got to learn about it in meteorology and my drone class at the same time, and so I learned through that class that also pilots do have to, learn about the METAR. So National Weather Service up there, bullet point number 2, they have on-staff meteorologists dedicated to writing TAFs. So little segments at the end of their area forecast discussions that are dedicated to the pilots. And so in my advanced forecasting class, it was one of the classes I listed on the right side of the screen back on those earlier slides, advanced weather forecasting, I actually got to write my own TAFs for a forecast event. So it was pretty cool, and it was nice to understand what entails with a TAF. Now, bullet point 4, this is actually true. The National Weather Service or any government entity can't really use drones directly. They can contract local officials, so emergency management. They try to stay away from private companies like Michigan Storm Chasers, but again, they go for emergency management, and so that way they can do their surveys that way instead. And so again, that's kind of the way they do it, and unfortunately, that's kind of what they're stuck doing. Drones are useful for storm spotting and, of course, surveying and research, specifically when a tornado goes through. Again, you can't really see everything on the ground, and when you're in the sky, obviously renting a helicopter can be expensive versus a drone, and so drones are very quick, easy, and as long as you have clearance to do it, you want to make sure you're doing it the right way. You're able to fly over an entire tornadic path in the span of 5 minutes. And you can see all of the convergent fields in the field. If there's crops, you can see all the trees that have fallen and kind of bent in towards each other. So drones are very, very useful, and of course in research as well, because there's still a lot we don't know about meteorology. There's a lot of different master's programs that are doing things. I will say this, Central Michigan actually sent out a crew. They didn't really use drones, but they sent out a crew to learn about lake breezes. Here in Michigan, we get those all the time, and they have a lot of stuff that hasn't been published yet. So that's just one example of research. There's other stuff out there in the United States that they're actually using drones for. I can't disclose, but drones are very useful when it comes to research in the field. Drones Michigan Storm Chasers, we are working on getting for 2026. This is one of our things that we're working on. For those who don't know, drone pilots, if they're going to be working commercially, they have to get what's called a Part 107. And that is because if you sell anything, it's very, very strict. If you get a cookie from somebody, that counts as payment, and so that's illegal without a Part 107. So every one of our chasers that does have a drone are working on getting Part 107s for this year. We haven't really had any drone footage on our page because of this, because we don't have any chasers that have the Part 107 yet. So 2026, that is our plan. We're going to have some of our storm chasers out there getting licenses for that. Now this is going to be about the hurricane hunters, if it ever loads. There we go. Hurricane hunters. How many of you guys have heard of these guys? Awesome. Yeah, these guys are the true warriors of meteorology and aviation in terms of flying into hurricanes. As you can see here, this is the hurricane hunters inside the eye of a hurricane, and this is what we call the stadium effect around it. Now, when they're in the center of these hurricanes, or when they're in the eye wall, they drop what's called dropsondes, kind of is in the name there, and they measure temperature, dew point, wind, and pressure. And so those ingredients tell us, as meteorologists, if it's strengthening or weakening, because they do launch these back to back in 3 or 6 hour increments usually if they have enough time to do so. And so we can see if it's strengthening, weakening, and especially if the pressure is dropping rapidly. If you have a low pressure system down near 900 millibars, then that's a pretty strong hurricane, and not many hurricanes have reached that limit. But ultimately, again, those are the guys that are really awesome, and we appreciate them so much when it comes to hurricane season here in the United States. Now this is a METAR, which I just talked about in our first slide about aviation meteorology. They're actually quite easy to decipher, so this is the easy part. I wrote out all the answers for you guys here. This is actually rather simple, and I took this actually from Willow Run Airport earlier today when I was making this. So the station, of course, this is your 4-letter code for Willow Run, KYIP. Next one there is your month, so the 4th day of the month, and the time it was taking at in Zulu. So Zulu is GMT time, so right now in standard time that's 5 hours behind. So that would be 2:15 in the afternoon. Auto just means it's automated sensors. We also have our wind here, so this is the degrees, so this is straight from the north, at 6 knots, so it's around 9 miles per hour. We also have our statute mile visibility of 10, which is pretty clear. Speaking of clear, there's your clear skies, and you also have the temperature in Celsius, unfortunately. But again, in meteorology, we did have to learn everything in Celsius. So pilots did too, and so everything there is -7 Celsius, -14 dew point, so that is a dry atmosphere, so not many clouds out there. Altimeter, so that's your pressure reading in mercury, so inches of Hg. And then down here is our extra remarks that sometimes are just one thing, and sometimes you have 3 or 4 lines of numbers here that you have to basically look at a book to figure out what it all deciphers. But this is, again, the temperature and dew point exactly. And if there's a 1 in front of it, that means it's minus. So 1, so -7 for temperature, 1, -14 for dew point, and it is an ASOS station. So that is meteorology and aviation in a nutshell. Next up, severe weather forecasting. This is probably the meat and bones of this presentation. There's a lot in here. And we talked about dropsondes, which are instruments that measure from top down. Now we got radiosondes, or the weather balloons, which measure from ground up. If we didn't have weather balloons, we would have no weather data. Your apps on your phones wouldn't work. We would have meteorologists that are pivoting back to 19th century technology to try and figure out the weather forecast. So if we didn't have weather balloons, we would be in the dark. So this is the most important thing. Measures temperature, dew point, pressure, humidity, as I mentioned. The balloon is filled with hydrogen or helium, never both, that would be bad. And once you get up to 60,000 feet, once it does pop, it comes down rather smoothly with a parachute. And over here on the right side of the screen is all of the National Weather Services that launch these weather balloons, usually twice a day, 365 days a year, and with 900 stations worldwide. It adds up quickly. So 1,800 launches a day, 365 days a year. You guys can do the math. It's a lot of weather balloons, but it is critical for getting severe weather or just forecasts out in general. Now, we at Michigan Storm Chasers also do weather balloon launches. We did 3 this year. They're quite expensive, so we had to limit ourselves, but these are the smallest balloons, actually, about 5 foot in diameter. They can get up to 50 to 100 feet in diameter. They're pretty big sometimes, but because we only want to measure the tropopause, we just measure the first 50,000 feet. But this is one of our first launches down in Athens, Michigan, back in, I believe it was June, with Chandler and one of our storm chasers, Annie. What's nice about this is the National Weather Service, they are limited to launching at 7 a.m. and 7 p.m. every single day. In the summer, that changes to 8 and 8. At Michigan Storm Chasers, we can launch at any time, and so with that, instead of us getting we're getting our information from them, now we're getting our information to them instead. And you guys know how it is in the spring sometimes, where you wake up in the morning, they launch the weather balloon when it's 30 degrees outside, and You get to 1 o'clock in the afternoon and it's 65 degrees and sunny. Well, that atmosphere you launched the weather balloon in is changed a lot in the last 6 hours. So, it's always helpful to have us on the ground, especially on a severe weather day, to measure the atmosphere as the atmosphere becomes more unstable. Had that down there as well. This is where it comes in with aviation. We do have to call the local FAA for clearance to launch these weather balloons, and usually it's about a 2-minute process. They get back to us relatively quickly, and they make sure that they got our location for this weather balloon launch. Now, this is the most confusing slide that you'll see of this presentation. It is a mouthful, but you don't have to worry about any of these numbers down here. This is the data that actually comes back from these weather balloon launches. It's plugged into what's called the sounding. This is the entire thing. The only things you need to kind of know and learn here are the skew-T, which is a 2D slice of the atmosphere. So here's the ground, here's the top of the trunk pause where the balloon pops. As that balloon is rising, it's measuring temperature and dew point there in the red and the green line. And over on the side, you also have your wind bars, so it's measuring wind and of course pressure as well. So that's pretty self-explanatory. We look at these for where clouds could be. So there's your red and green close together. That means that's pretty much 100% humidity, so clouds are likely there. Also, photographs, very important for severe weather forecasting. This is the measurement of wind in the atmosphere. So to give you guys an example of what's happening here, we're standing at that point, right in the center of the axis there, and we're looking either straight up or straight down. And because all the lines are over in that top right quadrant, that means the wind is coming out of this direction down here, so southwest. It's heading off to the northeast, and that is usually a sign of perhaps a little bit of straight line winds on that day. Now, if this line was curly in maybe 2 or 3 boxes at the same time, that'd be a sign of a lot of shear and spin in the atmosphere. So, not shown on that photograph, but that's what we would look for when it comes to tornadic days. Now, believe it or not, all of that data, all those numbers you saw, makes these pretty pictures right here, called model data. Now, as meteorologists, we have about 40 or 50 different sites that we use, or model data sites that we use. Most commonly, the HRRR run is the best, but each meteorologist does interpret the data differently, and we all use different ones and look at the history behind them all, and we got to determine which ones are going to be good or not. As you can see here, this is an example of July from this past year at 4 p.m. Same data plugged in. But, as you can see, over here on the HRRR, it has the storms firing along 127 and over in the Grand Rapids area. The FV3, on the other hand, 127 and points east over towards Detroit. So, again, as I mentioned, we have to figure out which are going to work out here. Again, the HRRR and FV3 are slightly different. And so this is where we either look at other model runs in comparison and see where the trends are shifting at that time, or look at our historical data behind some of these models. So that is why you guys often get a lot of different forecasts, because we're all interpreting the data differently. We all went to different colleges. We all have different tricks up our sleeves in terms of what we know about forecasting. And so ultimately, that's why we say you should only have maybe 3 or 4 different sources of weather information on you, because once you get past that, it becomes a little confusing. Now, this is our ingredients that we get from severe weather. M&M is over there on the left side of the screen for a reason. For those who don't know who M&M is, he has the nickname Slim Shady. And so, best way to remember it, Slim Shady, slim. Those are the 4 ingredients for severe weather, and really any type of weather. I'll run through them real quick here. Shear is that spin in the atmosphere. So as you can see down at the surface, you could have a south wind, but you get a mile up, and now you have a west wind. So that sudden change in the atmosphere is causing the air to spin around. That is shear. You get to lift, you need a forcing mechanism to get clouds up and going. So it would be a warm front, a cold front, a occluded front, a trough. Here in Michigan, as I mentioned, we do have lake breezes off all of the Great Lakes, and in the summer we often get those pop-up thunderstorms, and so that is our forcing mechanism. Another source, if you guys have been hiking before and have gone up a mountain and seen it raining at the top, that is what we call orographic lifting, where it forces the ingredients up the side of the terrain and causes clouds to develop. So it's pretty cool, and just goes to show you that there's multiple sources, both natural and unnatural, that go into lift. Instability, this is my favorite. The best way to talk about this one is think of it as a gas tank. The more instability you're putting in the atmosphere, The stronger the storms are going to be usually, and the longer they're going to last. So instability, that fuels hail, tornado, winds, every single severe weather type. Moisture, you can't have clouds without moisture, so you can have all three here, shear, lift, instability, but if you don't have moisture, then you're kind of out of luck. So that is SLIM. Again, this is all of it in text form if you guys want to see it again. Another thing to mention is you can have any combination. So you can have a shear day or just an instability day, or you have those pop-up popcorn thunderstorms as we call them with a little bit of moisture. You can have all four. But it won't matter because we have to look at step 5 here, which is what we call the capping inversion. The best way to remember the capping inversion, first and foremost, is included in all severe weather events, all forecasts, 10 out of 10 times. The best way to remember it, think of it as you're boiling a pot of water or some pasta, and you put the lid on. It's building up steam, but it can't go anywhere because that lid's on. Now you take that lid off, now that steam can rise up freely, and guess what? The atmosphere works in the exact same way. There is an atmospheric lid in the atmosphere that separates instability down at the surface from the instability above it. How that happens is we don't have a consistent temperature gradient as you get higher in the atmosphere. So that means it's going warm, 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 cool, 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 back to warm, and then cool, cool, cool again. For an uncapped atmosphere, you need it to just continuously go from warm to cool as you go up in the atmosphere. So, best way to remember it going forward, the capping inversion, put that lid on, no storms are going to really happen. Take that lid off, storms, game on, all severe types are possible. And again, it just depends on that day in terms of what ingredients are available for SLIM. Ultimately, after all of those 5 steps, these are the maps we get to make. These are the maps that I was telling you guys about that take about 45 to 90 minutes to make with the write-up, of course. The most important one here, I think I accidentally clicked the button there. Yep, there we go. The most important one is the red box. So if you don't want to confuse yourself, don't look at the rest here. A lot of people just want to look at this one here, which is a combination of everything. That is our normal severe weather outlook. So this is a combination of hail, winds, and tornadoes. So if you're interested in learning or want to see what hazards are possible for the day, that's where you separate your main severe weather outlook from these 3. I will give you guys an example of what these colors mean. So let's say we're over here in Jackson, for example, just because it's a city on the map. We're in a level 2 risk. That means at least one of these hazards is a level 2 risk. Look at hail. Nope, not quite. It's level 1. There it is. Severe winds, level 2. And tornadoes, also level 2. And so that means there's 2 hazards that are allowing this to be a level 2 for that day. Some days you can have no hail risk and no wind risk at all, but you could have a level 2 tornado risk, and that will still cause this to be level 2. So keep that in mind because the National Weather Service does it the exact same way. In fact, I won't bring it up now, but the National Weather Service Storm Prediction Center made it a lot more complicated than what we have in Michigan Storm Chasers for 2026. In terms of sharing the information to the public, they added hatched categories to it now for intensity. So we might have an educational post on our page at some point just to give you guys a heads up on what that means, but again, that is how these forecasts work. SLIM, also used for flooding risk. Again, you look for the M component in your soundings. We also look at a lot of different winter weather stuff in our SLIM. We also look for high wind events when we have sometimes bomb cyclones that come through, which you have a rapid drop in pressure over 24 hours. We can also check for fire weather, so that would be when it's very dry, so the red and the green line are very far apart from each other, and you have high winds that would result in wildfires. Also can determine the lake wave heights if you're going out for a boating trip for the weekend. That is one way we can use SLIM. Also, frost, fog, and the ever elusive freezing fog risk that we've seen a couple times this winter. And of course, you can use ingredients for the strength of an incoming hurricane. Again, those can be used in both radio sounds and drop sounds that are dropped from hurricane hunters, so pretty cool. Now over here on this side of the state, you guys don't get this too often, but when it does happen, they are called snow squalls. But over on our side of the state, we call them lake effect snow. This is how it forms. For those who don't know, this is when warm air is rising from the lakes that are open, and you have cold air passing over, usually. In the spring, that reverses. When you have the cold lake waters and warm air passing over, then you also have lake effect that way. As that air pushes this moisture that's developing further inland, the heavy bands grow taller, And eventually, these clouds become too heavy and they start to precipitate out as snow, sometimes rain, if it's warm enough. You can get lake effect rain on cool fall days, but usually it becomes lake effect snow. Different factors can result in this lake effect snow falling further inland, and so if you guys have been over on the west side of the state before, notice during a lake effect event there's maybe be 3 inches in Holland, but then you get towards Grand Rapids and they get 10 inches of snow. That is because there's a lot of different factors that are involved. You'll see it in just a second. Now we're going to back up real quick to the sounding, how you can see it, and how us as meteorologists can actually see it on the SKU-T. So let's science real quick. Snow forms actually best between the temperatures of 1 and 10 degrees. Once you get down to about 20 to 30 degrees, this is why people get confused why it's not snowing at 20 degrees sometimes. That is because the process of ice nuclei slows down, it becomes supercooled liquid instead. And so instead of snow, you're getting freezing drizzle. And that's why we get a lot of freezing drizzle days when the temperatures are below freezing. So this would be a perfect sounding for snow falling up here because it's in between 1 and 10 degrees. But you get down here to the surface, and there's your 20 to 32 degree range. So on this SKU-T here, you can see it's in yellow where it's 1 to 10 degrees, so that kind of helps us out when we're forecasting. You can see how deep that is. Ultimately, if we want heavy lake effect snow, we want that yellow line to be closer down there because then there's nothing undercutting it. And the wider we get it, the heavier snow will be to fall out and result in sometimes 2 to 3 inches per hour snowfall rates. Now here is all of the factors that go into lake effect snow, ultimately why lake effect snow is the hardest thing to forecast in the United States. I didn't even put on the right side of the screen that zone we call the DGZ, that yellow line there on the right side, but there's also 9 other factors that go into lake effect snow. Before I get into that though, you can often see that a lake effect snow map, a forecast, will look like this. But reality is often disappointing because this is the results of sometimes lake effect snow events. Now this is slightly exaggerated, they're not usually this far apart, but sometimes when we get these lake effect snow events where you say 2 to 5 all up and down the lakeshore, oh there's 2 and 5 there, but you're in Holland and you're like, oh what gives, that was a bust of a forecast. Or you go up to Newaygo and they're like, oh that's way too much, you guys under forecasted. That's just the results of lake effect snow thanks to all of the factors you can see over here. My favorite by far is probably fetch, not the type where you're throwing a frisbee around, but the fetch of the length of the lake available. So let's say we're in Holland, for example, the distance across, don't quote me on this, about 65 miles across to the other side over in Wisconsin. That's your total fetch available for lake effect snow. You go up to Montague, up there in Muskegon County, you go across the lake, that's about probably 50 or 55 miles across. So there's 10 miles less of fetch available for moisture to be affected up into the atmosphere. And so ultimately, when you get a wind that's straight out of the west on a lake effect snow event, you'll see totals up here in Montague that might be 2 to 5, or you get down to Grand Rapids, and because there's more fetch available, they have closer to 4 to 7, maybe sometimes localized pockets of 8 inches of snow. And that's just one. If you'd like to math with me, the arc displacement formula, boy oh boy, let's say we're where I'm at over here in Ione County, where I live, and I'm about 50 miles away from the lake. A 1 degree change in wind direction. What that means is if I have a lake effect snow band over my house in Ione County, that one tiny, like that, guess what? That lake effect snow band is now went from over my house to about 1.25 miles down the road. And so I went from 2 inches per hour snowfall rates to light flurries. What? So that's ultimately arc displacement, and that's one of multiple factors here that go into lake effect snow forecasting. And again, as you guys over here on the east side of the state, the further away you get from Lake Michigan, the greater the width in arc displacement will be. So if you get that 1 degree change over here in Belleville, that's about 140 miles away from Lake Michigan. It goes from over your house to now, math real quick, about 7 miles down the road from you. So that change, that 1 degree wind direction change, is often why you guys, it's really hard to get lake effect snow totals properly over here on the east side of the state, and it's very hard to forecast. So if it's hard over here, just imagine, you guys have seen it before, how hard it is over on the east side of the state. So that is lake effect snow at a glance, and why it's often the toughest thing to forecast. Now, if you guys want to storm chase or figure out for yourselves how to spot tornadoes on radar, this is actually useful information that you can actually use on your phone. Now, disclaimer right off the bat, I will say this, a lot of your free apps on your phone don't have what's called dual pol radar. It only shows you the rain radar. I'm going to be showing you guys examples of not only the rain radar, but a bunch of different products as well that can be accessed on certain apps. First and foremost, this is radar. The history behind it. It was used first in World War II, and they figured out, well, we can use it for radar and for storms coming too. So they brought it to the United States, and here in the United States nowadays, we have radar that covers every square mile of our ground. We have 4 in Michigan: Detroit, over at the airport. We have Grand Rapids, we have Gaylord, and we have Marquette. Surrounding Michigan, we have about 6 in the United States and a couple over in Canada. And of course, we call it the golf ball in the sky because, as you can see there, it kind of looks like a golf ball in the sky. So here we go. Here is reflectivity. So this is the radar that you guys always see on your phones. This is the intensity of the rain that's falling. Usually it depends on what app you have or what radar you're following, but usually the cooler the colors, the lighter the rain's going to be. The hotter the colors, the more intense the rain's going to be, and the larger the raindrops. And so often, when the raindrops get that large, they get circulated up into the updrafts of the thunderstorm, up in the freezing layer, and that's what forms into hail. That's what turns into these pink dots that you can see here. So that's reflectivity, that's your basic rain radar. Now, this is an extreme example of a tornado on radar. For those who remember 2011, Joplin, Missouri, this is that tornado. As you can see here, this is a supercell. We're looking for kidney bean shaped hooks here for supercellular storms. We have to go over, I'm going to stand over here because this is where I need to actually use my body as an example. Here is the wind radar, and the radar for this example here is over where I'm standing. So what's happening is on this wind radar, you have winds that are heading away from me at the radar source in red. Winds that are coming towards me are going to be in green. And so when we see these reds and greens get close together like that, that means you have 2 wind belts really close together like that. And the brighter the colors, that means the faster the wind is going to be. And so this velocity radar, or the wind radar as we call it, shows us the rotation in the thunderstorm. And also, besides tornadoes, you can also see if it's just one giant wall of bright greens and blues, that would mean straight line winds. And so this wind radar is very crucial when we're looking at tornadic storms. Now, dual pol radar is still relatively new. We've had velocity around for a long time, but we introduced what's called the debris radar in 2011. It's only been 15 years since we got this in the United States, but dual pol is very crucial for figuring out where debris is happening. So this is that radar on the right. We shifted the wind radar over here to the left. So this is a less extreme example. You still got your reds and greens close together there. And as meteorologists, we have to figure out where that might be matching up with debris on the ground. The colors entail uniform objects versus non-uniform objects. So reds and purples, because raindrops and snow droplets are circular in nature, they're going to show up as red and pink. And in blue, that is non-uniform objects. So that would be people's houses, people's belongings, obviously not circular unless you're chucking basketballs. So that's going to show up in blue. When these two match, when you have velocity and your debris, also known as correlation coefficient, right on top of each other like that, that is how the National Weather Service can issue a tornado warning, radar indicated, without even having a person there to verify it in the field. And so we're very thankful we do have this debris tracker nowadays, because 15 short years ago, it was just the wind radar. And you guys probably remember back in maybe the 2000s, 1900s, you guys had a lot of false reports because they're just looking at the wind radar, but they don't have debris. So we're very thankful we have it, and again, this is what we use as meteorologists. You saw that in our example of May 15th, that we had the wind radar and the debris radar right next to each other, and in that example near Hastings, you had the reds and greens bright, and a blue dot on the ground just southwest of Hastings. So that is how you read tornadoes on radar. This goes back to the Grand Blanc tornado, the one of the 2 that we saw coming about 10 minutes, 15 minutes prior to it happening. As you can see here, I will make this disclaimer right off the bat. As meteorologists, we're trained to see where convergence is going to be happening in these storms sometimes. And so for this event, we were walking through, everyone that was watching, that we had 2 lines of storms coming together like this. So you had the wind coming in up here from the southwest, And up in Flint, you also had another line of storms coming down from the northwest. And so all this wind was kind of converging in Grand Blanc. And you can see your velocity is starting to pick up there. Your reds and greens are getting close together. And you only need a little bit of spin to turn that green inside out and start rotating the storm. We were checking over on the debris radar. You can see there's not really any blues on the ground. It's picking up maybe a little bit of ground color there, so trees, birds. Those will also show up as blue, but there was no tornado on the ground. And again, it's about 10 minutes prior to it touching down, we were already calling out saying, hey, this is likely going to produce a tornado, especially given the fact we have converging wind fields. Now we get to 10 minutes later, and look what happened. This is when it was on the ground. It started raining downtown Grand Blanc. Some of you guys remember, I think it hit the GM factory there. That was where it got its EF2 rating, and it was ultimately issued a tornado warning. And as you can see, here's your blue dot for your debris. If you guys can see it over there, blue dot, and the reds and greens. My color table is kind of bad, I will say that in this example, but reds and greens very tight there, matching up with the debris ball, which at this point was 2 miles wide over our radar. So we were very concerned that this was a large tornado hitting at 1:30 in the morning where everyone was sleeping. So again, we were on top of it, and that's why we wanted to make sure that we were able to call this ahead of time prior to it actually touching down. So that is an example of tornadoes on radar here in Michigan and how we call them in advance sometimes. Other things that can be tracked by radar, just some cool things here, obviously tornadic debris. Hail cores also show up as kind of a greenish blue because that's non-uniform. You think of hailstones being kind of spiky in nature sometimes. You get all weird shapes and sizes. And so those will show up as blue on correlation coefficient. You also have the freezing layer. In fact, this is an example of the freezing layer because as the beam shoots out from the radar and Earth's curvature comes in, that beam starts to get higher and higher, and eventually it gets up to that freezing layer where the temperatures are 32 degrees, and you get maybe some sleet starting to form, and that is kind of rugged in nature. So you can kind of see how it's a ring around the radar about 3,000 to 5,000 feet up. You can also see wind speeds at a certain height with that velocity radar that I talked about. With dual pole, we can now figure out cloud top heights, so we can figure out if they're 50,000 feet up, that means it's a very strong thunderstorm. We also have my favorite, the buoyancy of the storm, so we can actually figure out if clouds are collapsing on themselves or rising up. That is with this little cool radar that we don't showcase often, but when we are bored sometimes, when we do show off the ZDR radar, and we can show you if it's a hot color on the ZDR radar specifically, that means the clouds are billowing up, positive buoyancy. If it was negative buoyancy, it would be blue and gray and it'd be collapsing on itself. So that's another way we can figure out if the storm's going to be becoming strong severe in the next 15 to 20 minutes, because we can see those hot cores on the ZDR radar. Ultimately, the fun part is we can pick up things that are not meteorological. So, birds, trees, bugs, windmills. If you have a bonfire next to the airport where the radar is located, it will show up on radar, so be careful, because then you're going to have the entire fire crew coming after you. But again, fires, road traffic can actually be picked up, and more. So, at night, with the inversion, it does bend the radar beam down a little bit, and so it picks up things on the surface. And so that's why I added windmills there, because if you are in the Grand Rapids area and you use the Grand Rapids Airport, there's windmills up by Mount Pleasant, up at CMU University, Central Michigan University, and in cold nights during the summer, that radar beam bends down, and it can actually pick up the windmills that are out there as blue on correlation coefficient because it's non-uniform in nature. So just a bunch of different things that can be tracked on radar. Basically everything you can think of, as long as it's in the range of radar itself. Now, we get to the fun part about storm chasing. Day in life of a storm chaser. I don't do this much anymore because I unfortunately am behind the scenes, but again, I have meteorological knowledge to give to you guys, so I let everyone else have the fun in storm chasing, but this is what it usually looks like. Back when I used to storm chase all the time. This is the vehicle equipment. Some of it is optional, some of it's kind of mandatory. On the left side of the screen here, laptop, mount, you have phones, ham radio is very important. I don't drive into hailstorms, but if you wanted to, put hail cages on hail cages on your car. We got amber lights. Also, all of your devices, obviously you need a voltage, you need a converter, so you have a converter, and sometimes cell service is not so great, so you need a booster. On the right side of the screen, we have things that, even if you're not storm chasing, you should probably have in your vehicle, such as a first aid kit, a blanket for both warm and cold situations. Technology sometimes does fail us, and paper maps, while they are obsolete, they are very useful for storm chasing. So definitely have those in your vehicle, especially if you're going on a road trip too. Flashlights, heavy duty work gloves, huge emphasis on that because you never know what you're gonna be picking up. Cash on hand. A lot of people don't realize, or they do and they forget, that if you go across state lines, sometimes your bank might lock you out of your credit card if they see purchases out of state. And so if you go storm chasing on a Saturday and they lock your card out and you have to call the bank and they're closed, you have to wait till Monday and now you're trapped in the plains with no source of income, or no source of money, excuse me. And so cash on hand is very important. Ultimately, you want to make sure you're staying properly hydrated and have plenty of snacks on hand because you don't know if you're going to be stopping often during a certain day. Now, if you're coming in from out of state, or just not at all, if you're just staying in Michigan, this is what it would look like for setting up a chase target area. We look at three things. Number one, the environment. Where is it going to be the most likely place to see severe weather the next day? We pick out between usually where the fronts are at, so the warm front, the cold front, this is just one example. We would make a green area on the screen. Number two, visibility is very important. We want to make sure that we're chasing where you can see miles and miles away. Here in Michigan, it's kind of hit or miss, and so this is an example of between Lansing and Grand Rapids. You have a lot of fields out here in central Michigan, and so we would circle the area inside of the screen box that would be favorable to see storms coming from a distance away. And lastly, if you're coming from out of state or far ways away, you want to make sure that you're setting up in that zone the night before, and so you're going to pick out maybe a hotel that's either close to or inside of that zone so that you don't have to drive often the next day. And so those are the three things that go into that. Now here's the National Weather Service's forecast that I was telling you guys about, how they do the level 1 to level 5 risk. So we look at these, and we always stress a good night's sleep, but these forecasts sometimes come out at 2 a.m. in the morning, and so, you know, we get the severe weather forecast out and we can't sleep, and so we gotta make sure we're still forecasting through about 3 a.m. in the morning. And ultimately, this is some of the products we look at, National Weather Service and our model data, of course. This is just an example from last fall, and so that was a severe weather event that missed us just to the south. So we just gotta make sure that our data is still up to date. A lot of people forget about this. If you're into videography, make sure you have enough storage on your camera. This one right here, very important. A lot of people start the day with an empty tank of gas and they try and make it as far as possible. And then they realize it's not a good idea when there's already 3 tornado warnings on the ground, they gotta stop for gas and it's a 10-minute delay. So right in the morning, fill up all the way to F. Also, healthy breakfast, because as I mentioned, you don't know where you're gonna be stopping, if at all. So fuel up as much as possible at the start of the day so you can keep that energy with you as you continue to drive. And for those who have gone on long road trips, you guys have probably noticed you get dehydrated a lot, so drink a lot of water, bring a lot of water with you. That's just the reality of sitting in the car all day. Now, goals and protocol. This is Chandler, one of his severe storms a couple of years ago, and went chasing in the Great Plains. A lot of people have different goals and protocol on hand. The 3 that storm chasers usually follow, this is 99% of storm chasers, they're either doing it for research, documenting, or storm spotting, so getting those reports to the National Weather Service so they can make those active alerts for that area. I say 99% because unfortunately there is 1% out there that does it for the thrill, and it's sometimes gets people hurt. It's just the reality of storm chasing, and so we want to make sure that you're not part of that 1%. Everyone in Michigan Storm Chasers is just part of the 99% in terms of getting those storm reports out to the National Weather Service and ultimately to you guys that are watching these live streams. Tornadoes are dangerous, that's pretty self-explanatory, but another reason why is because they also come in different shapes and sizes and they can change rapidly all the time. My first tornadoes, which I saw in Indiana back in 2021, went through 4 different processes. We had as a rope tornado, ended up being a concave side, straight side, and also a segmented tornado, all in the span of 30 minutes. So it undergoes a lot of different shapes and sizes, and ultimately the most dangerous one of them all is going to be right here on the left side of the screen. That's what's called a rain-wrapped tornado. That's just a decent example. That could be a lot more shrouded in rain if I really wanted to make it that way, but ultimately you wouldn't be able to see it. And so you want to make sure when you are storm chasing to stay out of its way if you can't see it. And so when I was storm chasing all the time, I would always be south or southwest of the storm because typically storms move from west to east. And if there's any turns, you don't want to be in the path of those turns. So ultimately, back off to the back corner is the best place to be. And again, when it comes to these tornadoes, they go through the occlusion process. So the north side of the storm is, a lot of people like to play it dangerous for some reason, which is not fun. On the north side of the storm is where all the hail's located. Not only that is, tornadoes like to occlude to the north, so they make a sharp left turn. We saw that in Michigan a couple times last year with the March 30th event and the May 15th event, where these tiny little tornadoes would be going straight to the northwest, and then they would do a 90 to 180 degree turn straight to a city that was not to get a tornado. So again, north side of the storm, not a good place to be. If you're going to storm chase, please be back out of the way and play it safe a couple miles from the storm. Unless, of course, you read timber and you just drive it home. So, again, with storm chasing, it's sometimes not a pretty sight. And this is just a reality of storm chasing. This, in fact, was a scene from our own state. This is the EF3 tornado that hit Gaylord back in 2022. And a lot of people did get hurt and killed from this tornado. So, when you're storm chasing, you do have to have the guts and the mentality to be prepared to see anything and help out in whatever way possible. I will say this, I will throw this in as a disclaimer, help out as much as you can, but make sure you're not adding stuff to the situation that makes it worse. So, as an example, I don't really have the CPR AED certification on me, so I can only help call out to people and perhaps transport people as needed, but if the emergency managers come on scene, they show up. My job is to stand out of the way and let them do their job instead. So again, you want to make sure that you are ready to help out in some situations, but ultimately if you don't have the qualifications, you do want to be out of the way and let them handle the scene. Lastly, be ready to change plans on the fly. So that green zone I was telling you guys about, you wake up the next day and all of a sudden the ingredients shifted 3 hours to the north. Now you're driving 100 miles for the entire morning trying to get to the new target zone, and so again, that data might be outdated. Also, I put that second bullet point on there as a valid reasoning. Sunscreen may not be a bad option because we have what's called blue sky bus days, where there is nothing but sunshine. That capping inversion I told you guys about came into play and prevented all that instability from rising up at the upper levels of the atmosphere. And so this is what's happening here is you have these cumulus clouds, the instability is getting stuck on the cap. It can't get past that cap. So it makes these cumulus clouds, but it doesn't go any further than that. And so a lot of sunny skies out that day, and I kid you not, I've chased a couple times in Illinois, and I've come back, went to the bathroom at night, and I noticed I was red as a tomato because there was so much sun on that day, and we didn't see anything. So not a bad option. It's not. It's kind of optional, but again, be ready to move and be ready to be disappointed in some cases if you go out storm chasing far away, because the environment does like to play its own game. Lastly, our last segment here, being prepared and safe during severe weather. Some of this is self-explanatory, and some of this may be new to you. So we'll run through it here. First and foremost, don't pull a Midwestern dad and sit out on the front porch, as much as it might be tempting to. Please get indoors. It is exciting to see severe weather happening sometimes, but again, you do want to make sure your safety is first and foremost. Top option, of course, is a basement. I didn't put it on here because not many people have it, but if you do have a storm shelter below ground, again, that is another option. If you don't have a basement, lowest floor interior room, if you have it. If you don't have any interior rooms, my best advice is a bathroom, usually with a bathtub, because the bathtub, it's porcelain, but it does count as an extra set of walls between you and the outdoors. And ultimately, you can also cover yourself in a bathtub and protect your head, which is our third bullet point here, protect your head. BFT stands for blunt force trauma. That is the #1 injury when it comes to severe weather events. A lot of people get hit in the head. And you guys remember back to school days, we were told to cover our head in the hallways, and so that is #1 reason right there. If you have no safe place at your house, relocate to reliable, substantial shelter. So that would be a friend or family member right down the road, a business that might be reliable, you name it. Also, if you're out driving, this is where this comes into play as well. Some people may laugh, but restaurant or gas station is a sometimes good option because they have a walk-in cooler. Those walk-in coolers have these reinforced walls, and I kid you not, people have survived inside walk-in coolers out in Kansas and Oklahoma, and it was the only thing that survived that gas station or that restaurant. So it may not be the prettiest place to shelter, but it is an option if you do run out of time. So keep that in mind. Back to ditch though, don't go high up, go low. The physics comes into play. You have the wind makes everything a projectile at higher speeds. You'd think, plastic silverware is not a projectile, but it can be at 100 miles per hour. So anything that's getting lofted in the air, that's going to hit you, it could go right through. So you got to be careful. And again, back to the physics, the wind is more likely to not blow you away if you're laying flat down versus standing out in the open. It's like standing in a hurricane, you don't want to be out there. So additionally, I didn't put it on here, but do not take shelter underneath an overpass. We talk about the tunneling effect. This is where you have the winds getting pinched together and speeding up as it gets pinched. It's like the wind going over a mountain. As it goes over a mountain, it gets pinched together at the top, and this is why you see Mount Washington out in, I believe, Vermont. They get these 150 mile per hour wind speeds every year. That's because the tunneling effect is taking place, and those winds are going up the mountain and getting doubled in speed. Overpasses work the exact same way underneath embankments, and people have died taking shelter underneath an overpass. So there's plenty of evidence out there of people who have not made it from that, especially back down in Oklahoma and Kansas. Bring your key valuables with you to your shelter. Usually that's food, water, a weather radio, and shoes. A lot of people forget about shoes because if you come out to a house that's destroyed, there's going to be a lot of nails and other materials laying everywhere, so you do want to make sure that you don't have bare feet. Again, you should have enough food and water to at least last you about 3 days, because again, if you're trapped for a while, you don't know how long you're going to be down there. And so we never want that to happen, but just prepare for the worst just in case. So always bring enough to last you about 3 days. This one comes into play here in Michigan, actually. Even in disarray, do not exit your shelter until you're sure of safety. This happened actually multiple times in Michigan. Most recently, Portage, Michigan had a tornado in 2024 down there. EF2 tornado kind of went through the south side of Kalamazoo as well. And we had body cam footage sent in from Kalamazoo Police Department, and you could hear and see people getting rescued from shelter, and the sirens are going off in the background, and the weather apps are going off on their phones, and you can hear people saying, that's not right, that's got to be from the tornado that already went through. It was not. There was a second storm that was coming through the exact same path, and it was 45 minutes after the tornado went through, and so thankfully there was not a tornado on the ground. At the time they issued it as tornado on the ground because someone falsified the report. This is why storm spotting is important, but again, there could have been another tornado in the exact same path 45 minutes later. If you guys think back to Palm Sunday here in Michigan, we had a lot of tornadoes on that day as well, 1965. Specifically, there was 2 tornadoes that went through Branch, Cass, Hillsdale. Some of you guys may remember this, down there on the border. EF4 tornadoes, same path, about 20-ish minutes apart. Correct me if I'm wrong, of course, afterward. I'm not quite sure on the details on that, but there were 2 tornadoes, EF4 in strength, that went through the exact same area, 20 minutes apart. And so people had stories of surviving the first, but not making it through the second from that event. So again, even if you are in disarray, do make sure that you're still weather aware if possible, because again, you don't know what's coming. If you're without technology, just make sure you're relying on somebody else. Here's a visual for you guys if you'd like some visual learning. Pretty self-explanatory. People ask me all the time for basements, where's the best place to go? Is it the south wall, the east wall? Ultimately, if you are below ground, you are perfectly okay. If you want to be better safe than sorry, still shelter in that interior room in the basement, because again, those are not technically exterior walls, but again, if you go in here, that is completely interior. And so usually people have interior staircases or bathrooms in their basement. That's a good place to be anytime there is a tornado warning or severe thunderstorm warning for your neck of the woods. Now, these are some of the ways to be alerted. They go from most important to least important. So starting from the top, going to the bottom. A lot of people think weather radio is obsolete. It doesn't really do anything anymore. It's wrong, first and foremost. Weather radio is the best option for getting weather alerts. They're relatively cheap, first and foremost. And it's like having a personal tornado siren in your house. They are very loud. It will wake you from a sleep. And again, they're also battery powered. So if the power goes out, you can use them when there's no other sources available. So weather radio's there. They also have add-ons as well. If you are sleeping and if you are deaf or hearing impaired, you can add a pillow shaker to these Midland weather radios. This is the brand that makes these. And anytime there's an alert when you're sleeping, it will shake the pillow to wake you up. So it's very, very useful. Number two, in the day and age of technology, and it's always advancing, is obviously we have a lot of phone apps on our phone that do give us built-in alerts. On our phones, everyone's phones in here, they also have built-in wireless emergency alerts. Make sure those are turned on. And so apps, wireless emergency alerts on your phone, all helpful. Number three, of course, here at Michigan Storm Chasers, anytime there's severe weather in the state, we will be live no matter what. So if you see a dark, scary cloud coming your way, just check our page. If we're live, that means it's severe usually, so that's an option. Some of our other social media sites do have notifications on them for when we do go live. Facebook is not good at that. It's not built for live streaming or notifications in general. And so we always say follow us at least on YouTube, even if you don't use YouTube all the time, at least set up an account and follow us there just in case so you can actually get the notifications for when we go live. And so that is an option there. Number four, local news stations also do a pretty good job at doing severe weather coverage. Some of these news stations, do have text message alerts that you can get on your phone as well. So that is an option if you would like that. I understand not everyone in here is interested in the weather. I'm not offended, it's okay. But the buddy system, this is where this comes in handy. If you know somebody in your friend group or your family group that really pays attention to the weather, they can give you those notifications in a timely manner, then turn to them as the buddy system. Ultimately, knowing before you go is also very smart. Here in Michigan, we do get those late breezes, especially during the summer. And knowing before you go applies to human meteorologists because a lot of weather apps aren't built for microscale features such as lake breezes. And they only use one model run, and so sometimes they're not looking at all the data. So sometimes we have people coming up to us saying, our weather apps suck for the day. They're supposed to be sunny all day, and we got 3 hours worth of thunderstorms in the afternoon that were severe. And again, your human meteorologists, like us here at Michigan Storm Chasers or the National Weather Service, will always put a bulletin out to start the day for the daily forecast mentioning pop-up storms. Of course, we're not 100%. Again, we'd have a crystal ball in our back pocket if we were, but again, having a human source of meteorology is better than a weather app. Number 7 is controversial. I will say that right off the bat. This is the worst to rely on. First and foremost, outdoor warning sirens only meant to be heard outdoors. If you can hear them indoors, congratulations, that's an extra set of warning, but not everybody can. Additionally, tornado sirens, outdoor warning sirens can only be activated by local emergency management. They're not activated by the National Weather Service. They're activated by emergency management, officials at your town hall, could be your dad driving down to the post office and turning it on in the backyard. It's a whole process, and sometimes these sirens don't work, they're outdated, they've been around since the 40s or the 30s, and ultimately they turn on and turn off at certain times. And the last one is sometimes there's different criteria for different counties. So in Kent County, up by where I live for Grand Rapids, they turn on the tornado sirens anytime 1 square kilometer or mile of the county is in a tornado warning. There's 170 tornado sirens in Kent County. And so if there's a tiny sliver of Kent County, a tornado warning, guess what? All 107 sirens are going off, and so the false alarm rate goes up. And here in Wayne County, over here on this side of the state, you guys have recently changed your policy after that one unfortunate fatality with the spin-up tornado that hit Livonia, if you guys remember that. They changed their policy. So now they issue the tornado siren, the outdoor warning sirens for every severe thunderstorm warning. So now we have severe thunderstorm warnings and tornado warnings, and so they issue the sirens every time any warnings are issued now. And so again, each county, each district, each township is different. Some counties don't have tornado sirens, and so that's why it's often easier to rely on one of these 6 options up here. And before I change to the next slide, if you want to take a mental note, we always say at least have 2 of the 6 before you get down to outdoor warning sirens down there. Last slide here, this is the tornadoes of 2025. It was a top 3 year on record with an asterisk because records only go back to 1950, but our record is 39. Again, we had 33 last year. Good news, even though we know 33 tornadoes is not really great news, good news is they're all weak tornadoes. There were no fatalities, no injuries in 2025, so everyone was doing a good job in terms of being weather aware. We also had 1 EFU tornado, which is EF undetermined. It's when we get a video of the tornado, but it didn't cause any substantial damage, and so that is ultimately what it's rated as. yeah, that's all the tornadoes of 2025, and just serves as a reminder that we do get a lot of tornadoes in Michigan on certain years, and some years we don't. If you go back to 2021, 2022, we only had 3 or 5 in the state of Michigan, and so that's why our average is 16. But going back to that asterisk, the word tornado was banned before the year 1950, technically. Reason being is they couldn't use it on air because it would cause panic. And so, if you used it on air back before 1950, it was called career suicide. Seriously, that's the history of using the word tornado. So, that's why we didn't have much data before the year 1950, and eventually in 1950, it was between 1950 and 1953, some meteorologists in Oklahoma City area saw a huge tornado outbreak coming, and they just said, you know what, screw it, we're gonna go ahead and use the word tornado and tell people about the risks that are coming, and got a lot of positive feedback, and that was kind of the pioneering into doing this full-time across the nation. So ever since 1950, we have all this data for every single tornado now. Back before 1950, they did still keep track of tornadoes, they just kept track of the strong ones. So think of like the 1925 outbreak, they have all the F5s and the F4s and F3s and a couple of the F2s, but anything that was weaker than that, they just kind of tossed out and just ignored. So that is all history behind tornadoes, if they were a tornado, and what we saw in 2025. Other than that, that is the end of the presentation. This is all of our social media pages that we have. Thank you guys for having me, and I will now open it up to questions here. Yes, back there. Yeah.
The strongest thunderstorm I remember was in August 1980 in the Detroit area. And I still remember this, the atmosphere turned green. What causes that?
So that is the sunlight reflecting through the tops of the clouds, and in some cases that's the ice crystals that are up there, and so that is usually a sign of hail that might be forming in a strong thunderstorm. So it all has to do with the light shining through the tops of the clouds. Yeah. Right here in the front, yes.
Do you ever get tornadoes up in the Upper Peninsula at all?
Yes, they do. Yes, one of the years, actually, in 2021, we had 3 that year, and they were all in the Upper Peninsula. They had none in the Lower Peninsula.
Which part of the Upper Peninsula?
Iron Mountain area.
Mountain with the wind.
Yep.
I have a question.
Yes, question over.
The weather balloons, how long do they go up for? How long do they stay up in the sky before you said they pop and then they come down with a
Yes.
parachute?
Yes. So the question was about the weather balloons and how long they last. The answer to that is they last about 60 to 98 minutes, depends on the rate of ascent. And then after that, they just stop cutting, they just cut off the data once it starts descending. So the total time once it descends is probably upwards of 2 hours. Another thing about weather balloons is they're biodegradable, and so they just fall apart. And the National Weather Service, they do ask you to return them sometimes, but otherwise they're just telling you to toss them away responsibly.
So you have to go find them once they come down?
No, they just
No?
come down wherever.
What
so.
about the equipment? Do they have you have GPS in those so that you can locate them?
Yes, but once they stop taking the data, it cuts off the GPS. So they can kind of estimate where it falls, like the general area, but once it starts descending, then the data gets cut off. So, but yeah, if you find one, you can return it. Otherwise, they just tell you to toss it away. They get about 20% of them back every year. Any other questions? Yes.
Last year, where there was some discussion about cloud seeding.
Okay.
Can you explain what that is and why they do it?
So this is a very controversial topic. Oh boy. So first and foremost, here at Michigan Storm Chasers, disclaimer: we don't do politics really at all. We shy away from that. We don't really put it on our page at all. But cloud seeding, it does exist in some capacity, but it's not in the strength that you think. Like it has a very big fail rate. Like it works I think the number here was 0.0002% of the times, and it serves as a reminder of how small we are compared to Mother Nature. I will give you an example of hurricanes, because I know people talk about cloud seeding with hurricanes, is the amount of energy that goes into a Category 3 hurricane is the equivalent of 10 billion humans exerting energy in a single day. We don't even have 10 billion humans on Earth. And so if you think of a Category 5 hurricane, that's upwards of about 40 billion or 50 billion people worth of energy exertion in a day. So it's a lot, and we are very small, and that's why the success rate with cloud seeding is very small when they do it. And it only really works in areas where they really need it. And so you guys may have seen Dubai, it works over there, but that's about the only place they've had a good success rate with. So hopefully that answers the question in terms of cloud seeding. But
What does cloud seeding mean?
so that is the materials that go in the atmosphere. It's like silver iodine. It helps the moisture latch on and precipitate out. So in the movie Twister, the new one with Glenn Powell, they kind of used it as they launched that stuff in the tornado. And because it's Hollywood, one truckload, as I mentioned, we are very small compared to Mother Nature. One truckload is not going to change and kill a tornado completely, but you would probably need, you know, a whole state's worth of silver iodine to probably kill one tornado. So we are very small. Like I said, we're very small when it comes to Mother Nature. So keep that in mind. So back there, yes.
Yeah, I have a question. I feel like anecdotally I've heard about Tornado Alley shifting a little bit over the past decades or so. Does the data support that?
So data going back to 1950, the hotspot for tornadoes in the United States makes a C shape. So you have different tornado alleys. You have the Corn Belt Tornado Alley, which is up where we're at. You have the Great Plains, the main tornado alley. You have Dixie Alley, and that's what gets a lot of the attention in these months, so January through March. And because it's the start of tornado season, it gets a lot of media, and people just toss it out there and say, oh yeah, this is where tornadoes are going to be now from here till the end of time. And because we get further into tornado season, you don't hear about tornadoes more often because then it's not really the thing. But as we get further into tornado season, the ingredients in the atmosphere are slim ingredients. They shift around, and so it changes depending on the months. And so you do have peak season in Dixie Alley in January through March and April, but then as you get into summertime, then it shifts back over into the Great Plains, and then as we get corn sweat season, evapotranspiration for our farmers in here, that evapotranspiration helps fuel severe thunderstorms up here in the Corn Belt. So it does shift around. It's not generally shifting to the east, but it does change depending on the month of the year.
That makes sense.
Yeah. Question there?
Yeah. Why are strong thunderstorms described as anvil shaped?
Good question. So why are the thunderstorms, the cumulonimbus clouds, described as anvil shapes? The reason being, I think I have a picture of my presentation, but it's like way at the end. But it's one of my slides I don't use. But anvil is when the cumulonimbus cloud builds up and it hits the top of the tropopause. So we talk about inversions. There's a secondary inversion at the tropopause where it becomes super stable. And so all that energy rushes all the way up to the top of the tropopause, and then it hits that ceiling and it spreads out. And so it goes in all directions, and it makes like a little hat, like a chef's hat, also known as an anvil cloud. So once it gets up to about 60,000 feet, it uses up all the energy, and eventually it's that stable layer. So it's pretty cool to see. If you guys haven't seen an anvil cloud before, you do get some of those in Michigan, and they're very fascinating, but also a great reminder that it's usually a very strong thunderstorm that's occurring. So very good question. Yes?
Have you been in Reed Timmer's Dominator 1 car?
Have I been in his Dominator 1? I was at that open house, I was in the Dominator, yes. So it was very cool. I don't even remember because it was so long ago, but yes, I was in the Dominator.
What was the other one that was built, the guy that was videoing?
The TIV.
The TIV, yeah.
Yes. Yeah.
Didn't Reed buy that one?
I think for a short while, but then he sold it again. So
Okay.
I think he sold every single one now, so. Yeah.
So I saw something with Reed he was talking about the TIV at the time.
Yes. Yeah, that was like the Rivals, if you guys remember the old
Yeah.
storm stories, storm chasers days back on the Weather Channel. Yeah. Yes, over here.
If global warming continues, how is that going to affect Michigan's future forecast for severe, especially tornadoes?
So, gotta be careful. I don't want people to hate me. I really just don't want to answer this question, but again, we can talk about it afterward if you'd like. We can talk about it.
Global warming would make more tornadoes, wouldn't it?
Technically, yeah.
Maybe.
Back there, yes. Yes, yep.
I admit to that, participating in Facebook, YouTube,
Yes.
all that stuff.
Yep.
I'm an old woman. How do you support yourself?
So, like, support us, so like in terms of like donations coming in.
The Michigan Storm Chasers.
Yes, so supporting ourselves, so we get sponsors, so local businesses, they pay for, as I mentioned, exposure-based advertising, so they pay us and we display their logo on our live streams and our graphics, and it's just, we sign a one-year contract with a bunch of different businesses, and ultimately that's like our biggest source of income. We get another 20% is just from social media engagement, and so that's like you guys just simply liking posts, sharing posts, and following. It's Facebook's like, we like that, thank you for using our platform, here's some money. That's basically what it is, and then another 5% is they give us, the memberships and merch, which is a very small fraction, but that does support in some ways as well. So ultimately, sponsors are the biggest thing. So, yeah. Over here.
So you had a green section for the Storm Chasers for when it touched down for them watching and recording. What is the time frame between that? So like, if you say, hey, they're gonna be right here in an hour, we gotta get there. And then you also said it was a 10-minute, it could change?
Yeah, with the capping inversion?
Yeah.
Yeah, it really, you do have to watch certain websites. So as Storm Chasers, we have something called the Meso Analysis page. So it's a redistribution of the wrap model run. It's updating every single hour, and it tells us the latest ingredients at the surface. So we call it the meteorological cheat code when we're storm chasing, and it tells us where the environment at that hour, at the top of the hour, is most prime. And so often we'll look at that and we'll see if we need to readjust based on that data, or if we go with our gut instinct and stick with the information that we had earlier in the day, because sometimes the meso analysis data says, oh, this is the hot spot now, and then it updates an hour from now and it's back in the original spot where we were supposed to go. And so that's one of the tricky parts in terms of storm chasing, is sometimes stick to your gut, because you never know, that might be the best option. Yes, over here.
What is dual pole radar?
So dual pole radar is the measurement of the electromagnetic waves both in the y-axis, z-axis, and the x-axis. The different wavelengths are able to measure things such as the buoyancy and the correlation coefficient and the size and the speed of these objects. Again, it was introduced in 2011. Before that, it was just one wavelength coming there and back, and it really only got us velocity and reflectivity. So yeah, we're very thankful that we have dual pole now, and they are working on getting phased arrays, the next thing. So that is, instead of doing one scan, it's getting just the entire atmosphere in one big scan, instead of doing one scan around, one scan around, one scan around. It's doing all the different elevations in one scan and getting us all the data back in hopefully in record time, but government funding, that's probably a long ways away, so we'll see. Any other questions? Otherwise, I will turn it to one-on-one time at the end for questions up here. Thank you.
Thank you, Joel. I don't want to give you a specific amount of time that you have to stay after, because I know you have a long drive home,
Yeah.
but if he's here, you're welcome to go up to him and ask more questions. But we do these presentations the first Wednesday of every month. So next month we will have a program on Wednesday, March 4th, and it will feature maritime archaeologist Wayne Musardi. And he will be talking about his experience recovering and restoring a Tuskegee pilot's aircraft that crashed into Lake Huron during World War II training over the Great Lakes. There's flyers for that too if you want a little more information, but you can sign up for that the same way you signed up for this one. Other than that, thank you all for coming. Be safe on the way home, and we look forward to seeing you again soon.